Grandpa? Whoa! Hey, my feather! Ah! What is this place? Where is everyone? Yikes! Huh? Ugh. Oh, the feather.
Hey folks, cue the fireworks. July's featured free marketplace content is here. This month, get in shape with custom shape volumes, grow vast natural environments with high quality assets and an unbelievable foliage plugin, procedurally create both stylized and realistic textures, and get out of a dry spell with flashy, magical effects. Top it all off with a permanently free ArcBiz Explorer for showcasing large-scale projects. Visit the marketplace to download them all. There's a lot to look forward to when it comes to Unreal Engine-powered games. With titles like Atlus's Shin Megami Tensei 5 and Gearbox Software's Tiny Tina's Wonderlands, over 20 new Unreal Engine-powered games were revealed during recent gaming events like E3 and Summer Games Fest. Help us celebrate the more than 80 games shown off this summer by visiting the Unreal Engine feed and checking them out. Over the past several weeks, we've been hosting a series of in-depth presentations relating to the key features of Unreal Engine 5 Early Access on our official livestream, Inside Unreal. Most recently, we've recapped UE5's animation features, which if you missed the live show, you can now watch on the Unreal Engine YouTube channel, in addition to exploring episodes on world-building features, Nanite, Lumen, and more. It's a bird! It's a plane! It's Superman and Lois! When tasked with creating the action-packed sequences for Warner Bros.' new TV series at film quality but on a TV timeline, Emmy award-winning VFX company Zoic Studios knew they would need to find new ways of working. Learn how their team used Unreal Engine to superpower the show's high-flying action sequences. GDC's virtual event is coming up on July 20th. We won't be missing out on the fun, and we welcome you to join us for some exciting presentations, including deep dives on MetaHuman rigs, crossplay with Epic Online Services, and a new UE5 technical demo from the Coalition. Visit the feed for more details on the show. Can real-time tools level the playing field for DIY creators? For the folks at Rooster Teeth, they cockle-doodle-doo. Find out how the fan-driven entertainment company uses Unreal Engine to deliver a whole range of animation styles from Red vs. Blue to their new show, Neon Konbini. Are you in Europe? Do you like 3D? Give us 4 weeks and we'll turn you into an Unreal Engine animator for free. Summer of Unreal, a course hosted by Escape Studios, is for CG artists who want to launch the next phase of their career. Sign up now for the free bootcamp. We're excited to announce a new learning path on Unreal Online Learning, HoloLens 2 Mixed Reality Production for Unreal Engine. In this set of courses, you'll learn how to configure the engine for the HoloLens 2, create an engaging user interface, and utilize eye, head, and hand movements for a natural feeling experience. Head over to the portal to start today. And if you're ready to add Featured by Unreal Engine to your credits, we're once again accepting applications for our Student Showcase, where we highlight the amazing work that you all send to us. Submissions are due by August 19th. Visit unrealengine.com/student-showcase for all the details. Now over to our top weekly karma earners, many thanks to Every Nun, Clockwork Ocean, Lizard89, Crew Dimer, Shadow River, T. Sumisaki, Blue Mind Studio, Nacho Monkey 2, Yuya Noboru, and Acheta Games. Jump into the world of Samshara in our first spotlight, Twin Stones: The Journey of Buka. In this challenging 3D platformer, play as the hunter Buka on his mythical adventure to save his colorful living world, along with the help of Shiva, the god of destruction. Play it now on Steam. Go on a stroll through the jungle in Raymond Monsanto's relaxing cinematic scene. They built the scene in UE5 Early Access using assets from Quixel, DViz, and Polyasset 3D. Pop over to YouTube and let them know what you think. And for fans of The Sims, Premac Elysium created this concept piece for what The Sims 5 could look like in Unreal Engine. Head over to their YouTube channel to see more of their work and let them know what other game concepts you'd like to see in Unreal. Thanks for watching this week's News and Community Spotlight.
Hey everyone, and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Victor Broden. Let me introduce Chance Ivy, Senior Technical Product Designer, who's helping me co-host the UE5 shows.
Hey everyone, good to see you.
Good to see you too. Today we're going to cover mega assemblies in the Valley of the Ancient sample project, and to help us in this endeavor, we've invited Aaron Langmead, technical artist and evangelist.
Hello.
Good to have you, and please welcome back Galen Davis, evangelist for Quixel.
Thanks for having me.
It's good to have you back. Right, so we're going to cover mega assemblies, and I already saw someone in chat wondering, what are mega assemblies?
Pretty good question. It's a good opening question, right?
Yeah, that's right. So, what what in a nutshell are mega assemblies, and kind of what led us to actually pursue them as a solution to many problems that we've got? Galen or Aaron, you want to give us a little bit of background there, and then kind of we can get into some of the nitty gritty.
Yeah, I'll start off with just a quick explanation of what they are, just so that people know. So if you've opened up the Valley of the Ancients demo, you've probably noticed that there actually aren't a lot of static meshes or what look like static meshes in the world outliner, right? If you go into this rather than static meshes, you're seeing all of these things called mass underscore, and they're blueprints actors, right? And these are the mass that we're going to be talking about today. And what they essentially are collections of very tastefully and artfully put together pieces of Quixel megascans. And
So,
yeah,
real
sorry,
quick, you might see mass in here a lot. That was just short nomenclature while we were working through naming a bunch of these things as well. So on occasion we may refer to them as such, but we mean mega assemblies, just as a heads up.
Yeah, so you kind of click on around the level and you open up some of these. You can see that we've got, I'm going to try and move my camera quite slowly because I know my connection's not great. But you can see we've got these really nice kind of collections of assets. And if we open these up inside our details tab, you can kind of see that you actually have all of the references to the instances. And these are each of the meshes. So whenever these are being put together, it will kind of intelligently collate all of these down into groups of instances. And inside the actual actor itself, we have a reference to two things, right? So we have a blueprint file and we have a level. And basically the blueprint actor is our reference inside the content browser. So if we open this up, we can see our actual blueprint with all of our meshes, and we can click on all of the instances and we can see all of those grouped together. And then we can also open up the level as well. And this level is basically what these blueprints are referencing, right? So they reference back to this this asset collection, and then we can do really cool stuff inside here, right? So we can start adding, we can modify, we can change all of these mega assemblies around, and then when we go back into our other level, we can right click and we can update, and then it will update that change across all of those mass or mega assemblies in that scene. And Galen, I didn't know if you want to add a little bit of drive, because this was very much a Quixel dream to get this stuff going, right?
Yeah, totally. So, I mean, if you're familiar with the library and you've browsed through the assets that we currently have that are available, notice that everything is kind of self-contained as it currently exists, right? We have individual assets that exist in their own 0 to 1 UV space, and they're just self-contained assets. And we've always wanted to do something that was a little bit bigger than that, right? So taking existing Megascans assets and expanding on that and curating some really awesome examples of what this content could all look like together if we were to sort of start kit bashing our own elements together. So mega assemblies are kind of the natural next step for us, is kind of the way that I put it in the presentation, and that we want to be able to give our users something that's incredibly detailed, but is way more intricate and complex. So some of the things to consider, like this example that Aaron's flying around here, this is a massive giant piece of rock wall, that has all this screed on the side of it. And there's just so much detail that actually goes into making something like this. Now, from a photogrammetry standpoint, if you were to just scan this piece one off, there are a lot of problems that kind of present just in being able to actually kind of go and actually reprocess this data. So the fact that we're able to use the instant static mesh workflow, take individual assets that actually have their own draw calls and have their own unique textures and everything therein, and being able to expand on that and create something that's much larger and more intricate and more complex, mean, that's kind of the dream, right? As far as creating much larger assets. And the thing that we really wanted to be able to do, I mean, the level itself is much larger than really anything that this team has tackled before. And so we wanted to be able to build it obviously very quickly, right? And so we needed Lego pieces essentially that were much larger than just standard Megascans assets, right? We have drone assets that went in for Moab, and you'll see those represented if you just search for Utah, in Bridge. But these assets for mega assemblies are even larger. Some of the pieces that we made are just absolutely gargantuan compared to some of the other pieces that you would see just normally in the library. And so that's kind of like the high level product understanding of like what the actual asset is. But one of the things that I would add to what Aaron was kind of giving, and I'm sure that Aaron, you're going to get into this later, but is that this is kind of like a prefab system, right? Like being able to sort of work in the way that we would normally kind of create games of creating, modular pieces that all snap together that, maybe then propagate out to like a building or something like that. This is the same exact idea. But one of the things that's really cool with level instances, specifically in pack level blueprints, is that you can actually edit these in context. So if I wanted to place any of these massive cliffs in the level, I could go in, break the instantiation and the larger container of these guys, and I could do that actually in the level and then save that back out, and all those changes then propagate down throughout. So I'm sure Aaron, you're probably going to get to that. So
I'll open that up now so that we can show it. But yeah, and I mean, doing that has a huge number of benefits, right, as well. So you do have the option, like Quixel do with all their scanning tech. They could go in and they could scan, some absolutely massive cliff face, right? But that asset would be quite impractical to actually implement. So even with Nanite, which could handle all of the geometry in there, you'd still have like a ton of issues, kind of things like your distance field would be a pain, then texturing that thing and giving it like enough texture space would be kind of really problematic. Then your collision, don't know if there's any others anyone can think of, but there's quite a few.
There's a lot in there for sure. Collision was one that was really interesting too. I don't know, Aaron, if you were planning on covering some of the issues that we ran into with collision specifically, but that was one of the things that we wanted to make sure that we weren't, really kind of making something that was totally impractical. So we actually had some custom tools that allowed us to recreate collision specifically for mega assemblies, and crunching through all of the triangles in order to sort of make new collision for that was something that the tool allowed us to be able to do. So yeah, that was a massive hurdle that we had to overcome this project and mega assembly specifically.
I think too, on top of that, like just the monolithic aspect of having a gigantic cliff wall. I mean, it's just that cliff wall now, and you might have 3 or 4 of those, but you can only get so far with reusing that, maybe skewing it one direction or the other before the actual scale starts to fall apart. So here it seems like you get in the best of both worlds, where you have this collection of smaller assets that make a larger asset that you can kind of kit bash around with that asset, but still keep that granular control that you would expect from having just a rock or just like a small surface. It's like doesn't compromise one side or the other taking this approach. Whereas if you just tried to kit bash this entire map with just the Megascans assets, it would have taken I don't know how long. But with these, you're not locked into that cliff face, so you're not locked into that ground coverage. It's just a really good, well curated and well thought out piece that can be used multiple places and then mixed up a little bit to keep some of that variety.
Yeah, and then you're also not losing those assets, right? Or you're not even technically generating a whole new asset when you're doing this, because it's still at the end of the day those base meshes that you were working with and you were using. So it's really useful for that kind of reusability of kind of like a group of base meshes. But yeah,
this is a broken one up. I
just broke one, and I'm just kind of taking apart some of these pieces. So like all of these ones in here, these are kind of, you can see some holes in them now because I've just I've just ripped it apart and started just tearing these. But you can see all of these different meshes that we use to kind of like create this one particular asset. And when we kind of first started talking about this, right, the kind of the Quixel guys you were talking about, it's like kind of working at almost like a fractal scale, right? So you could kind of take these, and then inside these nested objects you'd have kind of like these groups, and then inside of those you could have groups as well. So it was ended up being a really nice way of working, that still ended up giving you that handcrafted approach and that handcrafted feel, but it definitely sped up the production, especially when, like you were saying, you're working at this scale. And this isn't even all of the assets. I've only got like a tiny little section actually loaded in here just to show it.
And
There's
yeah,
also.
go
Oh,
ahead.
sorry. Go ahead, Chance.
I was just saying, I think it's funny you pull out, to that sky level view, and you look at the actor count over in the tree, and it's like, something like the entire map's like 12 to 13,000 assets in this view. But I mean, how many instances of actual meshes did that turn into, Galen? Do you remember?
Oh man, that number was all over the place. We were in the several million range for sure if you factor in all ISM components. So I want to say we landed probably close to 3, but I don't know for sure off the top of my head.
It's just cool. There's like that multiple levels of nesting of what is actually in the space there. So you're moving around only in number of actors, but it's actually a ton of these meshes that are in there. They're instanced together, so you're getting some performance gains there at that level.
So one of the other things that is really super important with this is that from a practical perspective of the things that we were actually able to go and scan when we were in Moab, there were components that make up this larger environment that we simply were not able to scan. There are just limitations as far as what we can stand on, how close we can fly drones to certain things, and where. And so one of the things that Mega Assemblies really empowered us to be able to do is actually create a much larger palette of assets to pull from. And so that is something that we simply had to have in order to reconstruct this environment. So we evaluated all the assets that we scanned one off. And then from there, our world builders worked very closely with the guys that were helping us actually assemble these assemblies. And we created basically like a list of the things that they needed in order to recreate this area. So that was kind of the general workflow and how we prescribed like the types of assets that needed to be handed off to the world builders.
Yeah, I've got another quick example here. So, kind of going through these, when you make a pack level blueprint, you basically get a few different options, right? So under the level instance tab, which is kind of under the hood what this system is using, you get a few different ways of doing it. So you can go in and you can do some context editing, or you can break that asset down. So you can use this tool, right, not just as a way of kind of building up whole areas of content, but you can almost use it like a stamp, right, where you kind of you drop in this collection of stuff, and then you just break it apart and you drop those actors to the world, and then you can do whatever you want with them. So like taking one of these, but let's say you want to create a little bit more secondary variation once you've put down that actor. You could go in, you could maybe delete a few of these bits, you could remove some of them, you could go in and add some more just to create kind of even more variation as you're going through. And all of that hasn't destroyed the original blueprint, because you could go in and you could drop in another one of these next to it if you wanted to, and that'd work absolutely fine.
Well, super cool. And I'm sure we did quite a bit of that for a lot of the ground coverage pieces too, right? You don't really see a whole lot of anything tiled or repeated very often in those areas. And even if you did, as you're stamping these things down, like it's pretty much as easy as Aaron just showed there, right? To go through and muddy it up a little bit and make it not quite look the same as things that are around it.
Yeah, and I mean we're working at such a high kind of detail frequency that actually for this particular scene especially you could get away with that. But even just this, you can kind of go in, you can just duplicate these around, and it'll just deal with it. It won't really complain. So it ended up being a really nice way of working, because I think initially we were looking at using kind of landscape for some of this stuff, but the way that kind of everyone was kind of building this stuff in the end, it just seemed like we were getting for this kind of scale of environment, we were getting some really good results just building these beautiful little sections.
Yeah, and one of the things
that's cool about working at like this nanite resolution here too is that these assets are obviously incredibly detailed. Several million triangles make up each individual ISM, which is really important because as you start to bash them together, if you consider what these would have looked like under regular kind of game resolution budgets, for last gen, let's say, when you butt those assets up against each other, especially like kind of those saucer pieces on the ground, you would get very polygonal indications of like where those meshes would interact, right? Or intersect rather. And so from there, you would need to do all these different tricks that we've leaned on for years, in pixel depth offset and RVT blending and all these different ways of kind of going about it. And with Nanite, you actually really kind of don't need to do that, which is pretty amazing because there's so much detail in these scans that as those saucer pieces are kind of right up next to each other, they create an actual pretty believable transition between them. And right now Nanite doesn't support pixel depth offset anyways. And so the fact that it's able to do that right now with just these assets out of the box just kind of proves the power of Nanite specifically in this use case.
And we trialed that stuff as well, right? Like I was pushing for ages for us to be like, no, for the floor we want to be doing, we want to be using pixel depth offset and try and keep it a bit cheaper on that stuff. But it was one of those kind of things where you've got this new tech, which is Nanite, and it's completely broken. Every rule people in the games industry have had to stick to on polygon count and geometry and kind of being careful about your asset placement and all of that stuff. And I think it took a few people a while, especially the ones, it took me a while to kind of get used to the fact that actually that stuff didn't necessarily matter as much anymore. And you could do that, and like you said, you reap the benefits of that with the geometry having such a high level of fidelity and detail that you can just mash that geometry together and it won't create that like nasty kind of straight edge seam that you see so much in games at the moment where they've kind of just mashed two objects together.
Right, through each other. On the topic of like kind of performance and kind of keeping budgets in mind, can either of y'all speak to some of the material draw counts, draw calls, implications they're using a system like this? Like, is it going to add to it? Is it going to be different than what you would have from before? Or?
So there is a cost involved in the pre-construction phase. That's kind of where your main one is coming from, and that's basically where the asset will do a check to see if it needs to update itself from the original level. But that's not happening inside the game once it's built and it's packaged, because obviously that stuff just doesn't get changed anymore. But then once you're through with that, you look at any of these actors, right? I've loaded in way too many of them now, so I'm going to have to scroll through to find some of them. But when you look at these actors inside the editor, they're just an instant static mesh, right? So they're just it's just another instance. And I'm trying to remember if we managed to get it so that they actually would batch automatically afterwards. I think that might have got added in. I don't know if you guys can remember if that ended up getting added. But basically it's all, they're all collated together. So the instance stuff is just like you were adding the meshes normally, right? So in terms of differing in cost, I guess the main downside at the moment with this current system is you've got a lot of excess instances, right? If you look at the back end, where you're starting to overlap that geometry, and you start to get a lot of instances that you just aren't actually using anymore.
Right.
But even Nanite, Nanite's doing such a good job of occluding that stuff and breaking the mesh down anymore, that to some extent that stuff doesn't matter as much until you are getting into those really crazy instance counts, and then maybe you do need to go in and break those assets and do some deletion of some of the back end stuff.
or combining some things so you can
Yeah.
move some of the loading from one to the other, or some of the load, I guess. Yeah, and on that note too, I guess a lot of those pieces of geometry that you might never see or that you're just have kind of behind the scenes would be more just be diligent in building these kinds of mega assemblies, kind of know what they're going to be serving, right, the purpose before you go into it, and kind of well form them that way, so you're not you don't have like a whole gigantic butte with just the corner sticking out, right, with a whole bunch of stuff that's behind it. And I think even here showing in that zoo, there's like a very broad range of sizing of mega assemblies that we had for the Valley of the Ancient project, right? Like you have some that are, I don't know, Galen, was it like 40 meters high or something, maybe larger? And some of these that are more like splats for the ground here that are in number wide by long. It's kind of hard to get scale here specifically.
Yeah.
Let me give you a meter cube for
There you go.
reference. There you go.
Yeah. So they don't always have to be gigantic, but they can be in this sense. Like this is really dense geometry, and then it's numerous pieces of that dense geometry that make a sizable space on the ground that you could use in numerous ways.
Go put a cube over one of these. They're a bit bigger.
Right on.
And so it's important to note that, like, obviously the project is available to download, so you can leverage all of these mega assemblies now. But one thing that everyone should be aware of is that we're actually doing a significant amount of optimization for this pack specifically, so that we adhere to some of the things that we chatted about on the Nanite live stream and on the Lumen live stream, for that matter. Like Aaron was touching on, there are some implications as far as meshes that are included as it relates to Nanite, and also as it relates to Lumen, in that just the way that it works is that obviously we're rendering triangles that aren't receiving any light, aren't really doing anything for the purpose of what it is that we have on screen, right? And so with that, there is some cost, right? And so with that, what we're doing is we're trying to create a more optimized approach to the way that we're building masks, so for mega assemblies. So right now, if you float inside of them, kind of like Aaron was showing, there are a bunch of meshes that could probably be optimized a little bit better. So this is actually a more optimized one compared to some of the other.
You've done too good a job on these ones. I need to find some.
Well, this is the optimized one, right? This
Yeah,
is the optimized view. Yeah. Okay. Yeah. So this is.
I'll find some.
Yeah. No. There's some really poor offenders for sure, but the thing that's great here is that you can use a lot of the modeling tools inside of the engine to actually do a lot of those operations. And so that's literally the way that our guys are optimizing these things. So you can literally use a lot of the Booleans and selection tools and all types of different approaches to actually kind of get that result. And as our team is sort of working through that process, we're reducing nanite overdraw, and we're going to be able to leverage even higher quality for Lumen kind of going forward. So that's something that Daniel touched on a lot, during the Lumen live stream, is that obviously, the most ideal conditions are something akin to like ArchViz, right? Like where in ArchViz, like pretty much everything is kind of met, exactly vertice for vertice, where they actually would actually truly intersect in the real world, where what we're looking at here in this Moab set is something that's a little bit more organic, right? Where we're shoving a lot of pieces together, we're creating a lot of overlap and all that type of stuff. So there is inherent cost there. And it's just something to be mindful of, right? And so it's something that on this project, we definitely kind of swung for the fences as far as that was kind of concerned. And going forward, we want to make sure that we're being really cognizant of that. And reducing the amount that we're kind of creating overdraw and reducing lumen quality as a result.
Yeah, and I would say, I'm sorry, go ahead.
Go on, Chance.
I was just say on the topic of overdraw specifically, I think Brian had a lot of really good things he called out in the Nanite live stream to, where you can profile pretty regularly to understand where you're making, some areas that are much worse than others, and how you can kind of, minimize any of that, any of those problem areas.
Yeah. And this was something that, I would say, I don't remember exactly what phase of the project later into the project that we decided to really kind of take like a more optimized approach to the way that we were building these things. So I wish that we could kind of show some before shots of the before, with the heat map here for the nanite visualization, because overdraw was pretty significant on a lot of the assets that we were looking at before. So you would get that really concentrated orange or even yellow kind of tint on a lot of the elements that sort of made up these assemblies. And our guys went through the process of actually really kind of being a lot more mindful in the way that they were constructing these things. As you can see, the grazing angles are obviously like where the overdraw really kind of stacks and gets really kind of offensive. But for these kind of large open faces on the front side of the cliffs and everything, that's where they spend a good amount of time just sort of reducing their areas where otherwise they would have jammed pieces in to sort of fill holes, or whatever it was going to be. And so we're going to be releasing a much more optimized and curated pack of these assets going forward.
Yeah, and I mean, just to cover this as well, just in case you didn't watch the Nanite live stream, this kind of visualization mode is showing basically where the geometry or the kind of the bits in yellow and orange are basically really close on top of one another, right? So that geometry is sitting really closely together, and because of the way Nanite works, because you're getting that kind of reduction in geometry as you're getting further away, that geometry can start to overlap even more because it's kind of starting to average a bit closer together, and that stuff is kind of where it starts to get really expensive. So you can kind of see it gets a little bit cheaper towards as I kind of move the camera around, and like Galen was saying, as you kind of get that kind of like lower angle approach, that's where you're starting to see that kind of crunching happening even more. So there definitely was a good amount of work that had to be done, kind of like midway, like maybe 2/3 into the Valley of the Ancients project, where kind of there had to be some work done to the assets to make sure that they weren't that kind of that bad. But what I found really amazing was that there wasn't really any drop in quality, right? There was just a bit more work done to make sure those assets were optimized, whereas before no one was really caring about kind of that overlapping and those stacking of lots and lots of instances on top of one another.
And I'll just give another shout out to the modeling tools, because the modeling tools really empowered the team to be able to do a lot of these types of things, as far as reducing the overdraw and also just sort of making basic manipulations to the meshes themselves. We are limited literally by the fact of these are the things that we're scanning, right? They have a certain shape. And as you start to bash them together, they're not always exactly what we would need to create something that's much larger, right? And so being able to just literally jump into the modeling tools, grab like an FFD or something like that, lattice, or just even like a brush, move things around so that it actually fits for the assembly that we're trying to build. I mean, the guys got super creative with the way that they were building things as it relates to mega assemblies. And without that tool set inside the engine, I mean, we'd be doing that in another DCC. Everything stayed inside of Unreal Engine for the entire creation process of making these. So it just another huge shout out to the modeling tools. They're awesome.
Yeah, and I mean they solved the collision problem as well, right? Like you mentioned it earlier, but basically every mass, usually or almost every mass, one of these instances will be basically a collision for the entire asset, right? Because we do not want to be having to handle collision for every single one of these small actors. It's just not going to work. It's not feasible. So,
well, especially too, if a player is never going to be over there, they're never going to collide with something, that needs high fidelity, right? I think there were some times when we were doing profiling where we had nanite level collision on some of these things, and we're like, oh yeah, we can go through there and clean.
Yeah.
The
So if you go over
stuff,
if you go over to the mass, packed, and collider section, you can actually see all of the collision meshes that were generated for each of these actors, and that was all done with a semi-automated process. I think towards the end, one of the tech artists managed to get a process that made this step actually super easy. So you kind of get this base collision that's representing hundreds and hundreds of instances, and it just meant that your collision's suddenly a lot easier to handle.
Yeah, because before, if you consider the fact that all these different mega assemblies had their own individual pieces that had collision going in, right? It's not very optimized to have collision for, let's say that there's 100 different components that actually make up just that one assembly that you're looking at right there. So being able to sort of do the Vox wrap operation. I think was like part of what he did, right? Marion, and then they sliced it back down to create something that was more optimized from that. I mean, the difference of having 100 individual primitives that make up the collision for a single piece like that, as compared to one large piece like that that just sort of envelops it. I mean, it's night and day from like a performance
difference.
perspective.
Yeah.
So.
Yeah, no, not a whole lot of interpenetration of that too, right? It's just
Mhm.
one for that whole thing, and so you've got mass to mass or mega assembly to mega assembly as opposed to everything that's happening inside.
And
Aaron,
especially with the way. Sorry, go on.
I was just Cordell just messaged me. He said that the one that you were looking at, there's actually an optimized version that's sitting behind it.
Wait, which
So,
one? This
like
one.
the one, yeah. So I think those are like an A/B of like what it was pre-optimization.
Oh,
So we can
okay.
actually see them side by side if you want to
Nice. Yeah,
look
yeah,
at
yeah,
those.
yeah, yeah.
'Cause,
Let's look at some overdraw comparisons and see the difference.
yeah, it's pretty awesome.
Yeah,
Big
yeah, there you
difference
go.
that you can see.
There you
So
go.
You can tell Cordell I've got some that are about 10 times worse than that and 20 times worse than that in chat right now too. Crazy. That's super cool though.
Yeah, it's amazing. You know, kind of with UE5, it's definitely made production easier, but there's different hurdles now, right, that you have to consider that maybe you weren't even thinking of in the previous production. So while it's definitely, you know, kind of we're getting a much more, you know, much improved visual fidelity, and it's definitely easier to work in. Like I've been building quite a few scenes using Nanite and Lumen and stuff, and it's definitely a nicer way to work and an easier way to work. But there are some extra steps that are still there that you need to be thinking about, and this overdraw thing and your instance count is definitely one of them. But I can show a quick step in just how you can start building these if you want to, if that sounds good.
Yeah, sounds great.
Yeah. So I'll start with a new level just to make sure that you know, kind of everyone is on the same page. And basically, we can do this from any level, right, that we want, and actually we can have these in pre-existing ones as well. So we could be working inside a single level and basically, you know, kind of putting this stuff together and going, oh, actually this will work nicely as a mega assembly. So you could kind of select all those actors and bring them together. But for this instance, I'll just do it in a blank level. So I'll scale up the floor a little bit. And I'm going to add another floor actually, and just put this at a bit of a glancing angle, just so I'm going to drop some stuff down, just as a quick demo.
Now, is that like a million triangles or 200 million triangles that box you have there?
This particular box is about 16 triangles, I think, or something like. So if we do, I'm just going to do my make box of actors. I'm not going to use the chicken because we looked at using the chicken and it was just weird.
bummer.
I'm going to just pick a. I'm just going to pick a boulder.
It's not too late to grab the ham.
Wait. Okay. Is it?
I don't know
What's
the
it
name.
called? Oh no, I don't know the name of it.
It should
Oh,
just
well.
be ham.
It didn't come up. Let's do. I'm just going to use this one. So I'm just going to make a bunch of them. So we'll just spawn a grid. Now we've got a bunch of rocks, and I'm just going to make sure they've got collision on as well, because that would be awkward if they didn't have any collision. Especially as I'm going to drop them with physics. And I'm going to make my floor a bit thicker as well, just to make sure that it catches them. There we go. That's a bit better. Fall through that. There we go. Okay, so we'll just simulate those and just let those drop. And then, cool tip if you didn't know, you can basically select all these actors, press K, and it will basically store their state. So even when we escape, those actors are still there, right?
Such a great little utility.
It's really, really useful. So basically, we've got the actors that we want inside our level. So I'm just going to save this first, and we'll do new mass example, and we'll just save that. And then basically, we need to. Where have you gone? There you are. And then basically, we just need to delete any actor that we don't want to be included, right? Because this will this will pick if we have these guys selected in here, it will include those inside the mega assembly, and then you'll end up with a brand new directional light every time you duplicate the actor, which we don't want. So I'm just going to get rid of all of them.
So it's not just static meshes then in that sense, right? It's just the actors that you're trying to get selected here.
Yeah, you can include those if you want to inside your because this is just a pack level blueprint, right? They can have other stuff in them as well. Same with your level instance. We just in this instance just want to have the meshes.
That's kind of cool though. You could do this and like have say like a campfire or something with it, or if it was like a part of like a big town set that you're building that might have little buildings or campsites near cliff edges or whatever, you could build a handful of those and have them to place around as well.
Yeah, definitely. You could put particle effects in there. Yeah, absolutely.
Yeah.
Everything you want to go in there. This is, this really is just kind of like a prefab system that lets you build it. But the nice thing is it's a prefab system that retains a link to that level, so you can go back and you can edit it. So anyway, once we've got our selected actors that we want, I've just manually gone through and deleted the ones we don't, just as a kind of a safety check. And then we right click on them. We can do that either in the world outliner or just inside the viewport. And we just go create from selection. And we get this little pop-up come up, and we can choose the type. We can choose whether we use external actors, and we can make some changes to the pivot, right? So we have 3 different options inside type: level instance, pack level instance, and pack level instance blueprint. And basically the core difference between these is that the level instance will just save this as a level that we can then it will then automatically convert into a level instance actor inside this particular map, right? Whereas the pack level instance blueprint will actually create a blueprint actor as well that will sit inside your content browser alongside the map. So for this, I just want the pack level instance blueprint. And Chance and Galen, please tell me if any of that made sense or not, because I can explain it more.
No, you're good. That was perfect.
Okay, good. And then we can tick whether we want to use external actors. So again, if you haven't come across external actors yet, that's the one file per actor system that we have inside UE5, which basically allows you to store each individual actor inside a scene as a file, which means that you can version it and you can do all sorts of cool stuff with it. So we can tick whether we want to use that or not. And then on pivot, we have a few different options. We can basically say whether we want to use the center of the selected actors and then the min Z, so basically the floor of this particular scene.
Good. That is so nice.
I know. It's so handy. Oh. You can tell that this has been used by quite a few artists already, because that's the exact kind of features that an artist immediately asks for. Or you can choose to have it centered, which just means it will take the center of the bounds of that selection. Or you can choose to have it be a specific actor, which is really, really useful as well.
It's great that it makes you make this decision, though, that's not going to take them from the world origin, right? Because there's no default that it will ever do that, it seems, right? Like you're going to choose something that is in the context of where these are, in the context that you care about where they are, as opposed to in the context of where they are in this current new mass example UMap that you've made.
Yeah, and it also means that, that just makes it easier if we're ever working in, some level somewhere and we've already got a level set up and we're just wanting to construct something, because otherwise you'd have to zero it out and move it, and it would be a real pain. So this way you can do it much more organically than I'm doing now, where you're building your environment, you see a collection of stuff that you think would be useful in other places, and you can just select them, right click, convert to a mass, choose center and min Z, and then you've got your actor and you're ready to go, and you can do whatever you want. So I can press OK. And then it's going to ask me to save some stuff, right? So the first thing it will ask me to save is the level. And this is basically going to be the level that will contain all of those actors, right? Because the level that I'm working in now is just an area for me to mess around in. It's not going to matter. We'll be able to delete that once we're done with it. But this one is actually going to be the level that is referenced by that blueprint actor. So we'll just call this mass underscore rock debris. Can't spell debris. Is it with a T? I can't remember. And we'll just do example.
No T.
It's no T. Okay.
Debris.
Is it IS?
Debris.
Yeah. Okay, cool. So we've got that. We can press save, and then the next thing that will come up is the blueprint, right? So it wants to then save the blueprint actor, and it will automatically append with just a BPP underscore. We can keep that, or if you've got your own prefix that you want to use, you can do that as well. And just make a note of where you're saving it. Mine's going to farm animals because we were doing some messing around, experimenting with it with that earlier.
A lot
There's
of
some-
chickens.
Yeah, there's a lot of chickens in that folder, and then we can press save, and then this will convert this. So just get rid of that. This will then convert this into that packed blueprint, right? So you'll see that all of those static meshes that we had in the original scene, they're now gone, and we've just got this this blueprint actor, and that blueprint actor is referencing this particular level. If we open up that level, and we're just going to go into unlit because we haven't got any lights in here. You can see we've got all of those rocks, and those are at our standard ones. So if we ever want to go in and edit this, like let's say we don't like this particular rock, we can delete that and save it, and then that will be updated across the blueprint whenever we need it. So I'm just going to get rid of these guys because I don't like them, and I'm going to press save, let that clean up, and then we can go back into our ancient map, which might take a second, but we'll see. Gonna need some filler, guys.
We got many seconds on hand right now, so you're good.
Cool. So I'll just let that load, and then we can basically go back into any map we want, and we can drop that actor in, right? And now we've basically got that actor that we can use anywhere in any of the scenes that we want to work in.
Oh, that was too quick. I was going to see if I could cherry pick a question or two.
Yeah, I was
but
gonna grab one too.
it's there.
Too slow. Okay. Yeah. So let's just pop back over to here. We can go in, find our asset, which is inside farm animals, and we've got our BPP mass rock example. I'm not going to look at the chicken one because it's too horrifying, and we can just put this in the scene, right? So we can move it around, we can rotate it, and it's just rotating all of those actors. So we can kind of rotate this until it kind of fits. And then we've got those rocks now in this scene, right? So they can kind of just sit on top.
And that should still work too with like the hotkeys for like telling it to snap to ground with end or those kinds of things. Using that origin point.
Using the origin point.
Cool.
But you'll probably, depending on the scene, you might need to do some more, a little bit of extra work to it and stuff.
Right.
But yeah, you can, you've got those options available to you because it's just another actor, right, inside the world. And yeah, so there's a few other things that you can do with it as well, because this is also a level instance, which is basically using the same system but without the blueprint actor referencing it. But yeah, that's basically how you make one. Super easy, and they're really, really useful.
Great. I'm actually going to grab one of the questions here too. So from Mr. Tegs here, are using these mega assemblies more performance friendly as opposed to just several instance static meshes? And I would say it's roughly the same at that point. Would that be appropriate?
Yeah, they're similar because they're just containers of static meshes. So there might be like so like I said before, there is a cost with the construction where it checks, do I need to update? But that's inside it's actually, I think it's before the construction script even fires. Inside the blueprint, there's a little bit of code that goes, do I need to update? And then it will do that check. And you can also trigger that to fire manually as well. So if you right click, you can tell it to update the packed blueprint, and it will just do a refresh on that particular object to check it.
And on that note, would you be able to take changes to this one here and propagate them back out to, like save back to the one you have in your content browser, and then propagate those in the level?
So you can edit the context. So if we just edit this one, you can see it kind of does that really nice isolation where you can kind of see that. So you can make an edit to this one. I'm really messing up this project. I'm going to have to do a clean download afterwards because I've completely messed it. And then we basically go and find this guy here, which is the reference to it, and that's going to be in green. We should be able to find either the commit button, which should be at the top. I think you can do it inside the right click as well, but we'll just do it on on this one just to keep it easy. And commit changes, save selected, save
Cool.
selected, and then boom, that one's now saved. And if there are any others of this one on here, which there probably are, that should be propagated across to all of those as well. So
Look for the floating rocks.
I'm looking, look for the flow. I'm just going to click on one that has the same name and hope that it's the same actor. That one. Go to it. There it is. So we've got another one, and it's got the floating rock. So I've now successfully ruined this this particular mass. We need to go back in and change it. But we have a similar thing with the create instance as well. So if we go to our place actors, find a level instance, we can actually drop these down, and these are literally just actors with a particular asset reference. You want to be careful with which one you place in these because it could be a very large one, but we can just pick one of these, right, and it will just give us the collection of actors inside this level. Do that
Very
one.
cool.
There you go.
So in many ways, it works similarly to blueprints. Whenever you make a change to things, you can have it propagate back out. It's super nice.
Yeah.
And nice too, because you can see it in context while you're working.
Yeah, this just has it gets rid of that kind of in between. It's just referencing the level at that point. So you can do the same stuff to it. You can click on it, you can break it, you can go in and you can edit it, and you'll get the commit option. And that kind of thing. It just has with this version, I think you get some extra content because it's actually referencing the level, so you get the benefit of it holding the level. Whereas with the blueprint, it's really just instant static meshes. Whereas this one, it's actually the actors inside the level, so you can kind of see it inside here. So there's a little bit of a difference between those two that you need to keep in mind.
Joe Burns was wondering if you have to keep both the mass level instance and the blueprint files.
Yes, because they're basically the references. So you have to keep those actors inside the content browser when you're dropping them in, because otherwise it loses the reference to it. So if you took one of these and you got rid of the level reference, or you deleted this level, it has nothing to reference to, so it doesn't know what those actors are supposed to look like.
Oh, so it's like the template that it's supposed to look back to.
Yeah.
Got it. That's pretty
So
cool.
it'd probably be fine. And then whenever it refired that construction script to update what that map's supposed to look like, it would just get rid of everything. Which
because
probably don't want.
I'm not supposed to be anything, so become nothing.
Yeah.
That's funny.
So you can look at that map then a little bit like the editor scene for that mass blueprint.
Yeah, absolutely. It is literally just the reference point for those objects, and then you can go into that level and work on it standalone, or you can do it you can do it separately. But it has lots of benefits to it, right? Because if you've got, let's say you're outsourcing some artwork, and the people that you're outsourcing to maybe you don't have as high a spec machine to be able to open kind of like all of this level, right? They can work on those standalone levels and edit those little set pieces and those little diorama pieces, and kind of make them, submit them without getting in anyone else's way. And then the kind of the level designer, they can maybe use a slightly beefier machine, and they can place those actors inside the world. So you get that really nice kind of kind of shared resource of the work.
Oh, that's very cool.
Yeah.
Right. There was one over here that I was gonna ask. It came up a couple times, and we called it out. I just don't want to forget it. And it was about what kinds of things can be in a mega assembly, and it's just pretty much the Unreal actors, right? Like the U assets that you have, you can combine those things into these pack level blueprints. They can take lighting, they can take effects, they can be in motion too. Like it'll simulate the particle effects if real time is on inside the editor. Is that correct?
Yeah, that's right. So the pack level blueprint will hold any blueprint actor or almost any blueprint actor. But then if we're talking about mass, that's actually something that's coming from Quixel. So it will be one of these prefab scenes. So Galen, I don't know if you've got any sneaky plans that you can tell us about for what you kind of envision mass to be, or the mega assemblies to be, and whether they'd include anything other than static meshes.
Sure. I mean, we don't want to be careful, but we are planning to release like a lot more of these types of assemblies. We have already a massive library filled with over 15,000 assets in it, right? There's a good chance that we'll likely go back to the well with a lot of the things that have already been scanned and reconstruct mega assemblies like from this existing ecosystem. So if you go and you just sort of see like the types of things that are already existing inside of the library, it's a pretty good indication of like some of the things that we'll likely create that would make up larger assemblies. And then obviously, what's cool now is that now that we have the idea of mega assemblies and the way that we're approaching them, the way that we want to actually be building them in mind, this directly informs the way that we're scanning. So it will save us time when we're actually, boots on the ground, evaluating the environment that we're looking to scan. It will help us be able to maybe identify elements that we know that we could otherwise kind of create from mega assemblies, as opposed to just scanning it in one giant element and have that be like a one-off drone component. Another thing is that we're really super excited about the possibility of using like physics to basically scatter debris like on top of assets and those types of things, and then baking those down into the components that would make up the elements. I mean, if you consider like really, really small pieces like twigs and even just like small pebbles, right? That's where, at least for us, with photogrammetry, some of those elements don't hold up the best, like when they're a part of something that's much larger. Now, if you separate those pieces and you make them so that they're basically standalone components, right? Smaller twigs or smaller pieces that sort of scatter on top of that, and we can get higher resolution from them, better performance, nanite quality, all those things, right? I mean, it's a win across the board. So we're definitely going to have some pretty exciting stuff, I'd say, as it relates to mega assemblies in the future.
Super cool.
Yeah, I keep on literally just finding nice camera angles for this and just sitting there about, oh, that's nicely done. Yeah. Just I wonder how much time we actually spent on this project just once we got to the stage going, oh yeah, that looks nice. I'm just gonna leave it there for a few minutes. Yeah, I see some in the chat as well. I'm sorry, we do keep on using different terminology for some of this stuff. But yeah, like the best way to think about it is that you have the level instances, which are levels and an instance of that level, right? So everything that exists within that level, there is an instance of it and it can be dropped in the world. You have the packed level instance blueprint, which is not a great name, and everyone at Epic knows it. So we'll look at changing it, which is a very similar thing, but it's basically holding the level or the contents of the level inside a blueprint actor that you can drop within the any other level. And then you have mega assembly, which are kind of like a subset of the packed level instance blueprint, or the packed level, which is a collection of Quixel mega scanned assets that are kind of very, very tastefully and nicely put together, so that you can kind of download those and use those, kind of as is shown in this demo, and kind of place to create your scene in your world. Just having a quick look through the chat, seeing if there's some others. So not a question, but there was a thought about the memory impact of using this. And that's a really good question, but it's actually, if you think about the difference between using this method and using basically a specific actor for this is technically cheaper, right? If you were looking at it in terms of the amount of memory on disk, right? Because we've brought all of these actors together, we've got this whole library of meshes, and we're using that exact same library to create every single different variation of these. Whereas if we were doing this any other way, we'd still need that library, but then we'd also need the actual, kind of the separate mesh that made that particular asset, right? So the actual impact on memory is is pretty good because we're still just using that base thing. And then at the end of the day, all we're storing is transforms, right? So for all of the instances, so the actual memory footprint of a mass is pretty small because it's just, kind of this instance or this many instances at here, and here, right? And then this one here, and here. So it's super cheap from that point of view compared to, kind of generating brand new content for every single permutation that you'd need.
Well, and on that note too, working with like world partition, right, and one file per actor, instead of having 2 million instances that are all individual actors in our file, we had that 12,000 that was the actors themselves too. So, just less to manage on disk as far as those kinds of, collaborative open world workflows go too. Because if these were all exploded and it was every mesh that was in there and we were tracking them at that level, it would be that folder would be very large in comparison to what we were able to accomplish using these. We got a bunch of questions over here too. I'm trying to dig through
Oh,
them.
do we? Okay.
Yeah, there's a doc. The team's been collecting them here, and I'm trying to catch up on them right now too. Aaron, one thing we had talked about too before, before we went live was you had early on in the project a spline tool.
Oh yeah, sure.
That you had used to kind of quickly. I mean, Galen, this was one of those really super cool moments that we had early on, where it's like there's a lot of artists were like, "Oh my gosh, that is really really amazing way to try to build out something really quickly with masses and other blueprint tools that we had built, for other procedural generation, whether it be for like building a fence or building some sort of literally anything on a spline, like the river system. But using masses with splines here, we were able to build like entire cliff sides, right?
Yeah, it was one of the things we went through a lot of experimentation on the on this project.
Yeah.
When we were going through. So we had this basically this tool that I kind of built where it would basically reference a mass actor or a group of mass actors, and then it would allow you to just spray them along a spline, or you could project that spline onto a particular shape. So we kind of drop this mass in, and then you could basically just pick them from a list. So see if I can do an example of this. So you had an array of different masses that you could use. Just try and pick a cliff one.
And this is just a blueprint that you have that you just dropped in the level, right?
Yeah, it's all blueprint. So we can this guy. See if I can pick a good one. We'll show you this stuff off.
Yeah, it was a bummer. We didn't end up using this specifically for the project, but it was definitely something that we evaluated a lot. I think we talked about this on, I want to say it was probably like the Nanite stream, but we looked at some different ways in which we were actually going to be able to build this level from a procedural standpoint, relying on some tools to kind of get us there. And so this was one of those tools that went through a lot of those cycles, just in sort of evaluation and figuring out whether or not we could do it. And then, the other thing was that we were evaluating PFVs for a long time, the procedural foliage volumes, if you guys remember that.
God, way too long. We were evaluating that for way too long period of time.
Yeah. Part of the process, I guess. Yes.
Yeah, absolutely.
Yeah, why I wanted him to show this is like it's just a super cool way to use workflows that you're already probably used to in Unreal to build like out using mega assemblies or PEC level blueprints to really build out large areas of slightly noise, slightly different I guess stamps of the same assets within a handful of seconds, right? And then go in there and actually make the edits to the individual instances you need or dress them up as necessary. But yeah, Aaron, how big is that? Do you have an idea how big that mass is, and then how long that range is? It's got to be just unbelievably large, right?
I'll put there's your meter cube.
Yeah, there's a cube, right,
in the world, right? So yeah, it's quite a lot. But what's quite nice about this, so it's basically it's reading the mass that's inside this mass list, and it figures out. So it takes all of the instances. So this is a reference to basically all the instances inside those, and then it places all of those instances along a transform. So it sounds quite complicated. It's really not. It's just reading data that's already there, and then it's basically letting you place all of those along this spline. Whoa, gone in the middle of a.
Didn't you add
rock there.
I think it was like a skirt modifier also to it?
Yeah, so you can add. So there's loads of different options in this that we were trialing. So you could drop scree down as well, and you could choose different mass. But yeah, one of the really cool things you could do with this is you could actually tell it to just drop those mass down. So you could use it as a stamp. So you can kind of scale these guys up and down, and then once you're happy with it, you could just drop them. And it would basically let you drop these as like whole mass. So these guys underneath are now whole. These are actual mass actors that have been spawned into the world. So you could kind of just do that. You could drop another set if you wanted to, and this works even better when you start adding more mass in for it to kind of vary between. And you could even drop them in as meshes as well. So you can kind of go in and you could actually tell these guys to actually drop down like the whole meshes. So these ones are actually the standalone meshes now that you could use.
Very nice. Yeah. So
And
it
these
breaks it
ones
all the
are
way down.
the whole mass. Yeah. So you could kind of choose how you wanted it to break down. And then if you didn't like it, I kept references to it all as well. So it actually, when it generates these mass and these meshes, it tags them all with the references. So if you don't like it, you can just tell it to delete them, and it will just clear them from that selection.
But it's super cool too, because using a combination of this and some other blueprint logic, you could, automate a lot of that to do some of the variations that you want over time, right? Just reseed,
Absolutely.
reseed, and then that's close enough, explode that down into the assets I want, and then go in there and change them.
So yeah, the this is it's 100% blueprint in here as well. So it's literally just it's choosing whether you want to, kind of spawn scree wall meshes, which are just kind of like standard meshes, or the mass themselves, and then it just goes through, grabs the mass data, it finds each of the instances, basically gets the transforms for all of those. So I'm just storing all of that data inside a bunch of transform arrays. Same with all of that stuff. And then once it's got all of that data, it just spawns them, right? So it just goes through and basically follows along that spline, spawns all of the all of the instances inside of that. So you've got those references still. So it was one of those things where I just didn't work quick enough to get this system up and running, mainly because it's new tech and we were still figuring out what the hell was going on. But I'm using this now in my projects, so it worked quite well for me because I've got this nice new tool now, and you can basically just you can pop it anywhere you want. You can project the spline as well onto different surfaces and things like that. So it was really handy for that kind of thing.
It is.
Oh, sorry. Go ahead.
I was just gonna say it's never gonna get old watching someone just quickly, just create hundreds of millions of triangles and just like reseed it super fast, and like create like this entire wall, hundreds of millions of triangles, like just on screen, like for what he just did. Just the engine slices through it like butter. It's crazy.
Yeah, it's just crazy, isn't it? Like these, just to show you, like those are all the meshes that I just dropped. So, we're now like, you can see the gray bits, the actual collision mesh that it's generated for that. And that's, those are all the meshes that it's like, yeah, that's fine. Just whatever you want.
Yeah.
We had some questions in regards to that collision. Laura's just working if it's possible to for us mere mortals to get access to the collision generation tool.
So the collision generation tool, it's actually part of the modeling tools, as far as I'm aware. They literally just used the Vox wrapper, the voxel wrapper for basically, they just took all of the meshes and then just generated the single asset from it, and then just kind of picked a resolution that worked well. And then they saved that out as an actor. I think the only bit that was automated was basically the actual process of it going through and doing it, but you can do it manually inside the current tools that are available.
I would need to double check on that though, because I'm pretty sure that we were using. Well, yeah, it's a custom tool, but it's I think we were using some elements of the Nanite proxies in order to kind of generate like the at least the basic resolution for that, because the modeling tools weren't able to load in all of the different instances at the resolution that they were, and so pretty sure that there had to be like some amount of the proxy, at play to kind of get us that
Right.
end result.
Yeah,
So
yeah, sure.
Probably dig into that a little bit too and try to get some
Mhm.
sort of direction on it or
Yeah, and I'm
next step.
sure if we cover some in-editor modeling in the future, that would be an important aspect to cover as well.
For sure. There's one on here was a question about using a lot of blueprints for making these things and the question around performance. So there's not really a whole lot of performance issues here. These aren't ticking actors. The blueprint is basically the thing that collects them together, right? And
Yeah,
the generation using here is all edit time, right? It's construction script driven. As you move things around in the viewport here, it's just changing everything that's in the space. And then runtime, it's not ticking. It's just a container, if you will.
yeah, that's like 100% it. It's an editor only thing. So you might see some slowdown if you spawned tons and tons and tons of masses using this tool, but only in the editor. So once you drop them, they're either just regular mass or they're just regular static meshes. And even when you put them in, they're just it's basically a blueprint similar to your pack level blueprint. To be honest, it's just a blueprint that's containing a bunch of instances. So the cost is negligible. The only process time is basically in that construction phase, or like Chance said. So yeah, the actual game impact is nothing.
Super cool. Just wanted to call out to the audience that we've got a number of questions in here that are not necessarily specific to what we're talking about today, or that we don't really have the folks that can answer them today. So thank you for your interest in those things. We're not going to be able to get to all of those for sure today, at least the people we've got. So we encourage you to come to later live streams or drop your questions in the forums, and we can see what we can do to answer some of those things. But good.
On that note, if you're watching this post live, essentially on YouTube or Twitch, and you do have questions for us, feel free to hop over to the forum announcement post where sort of our conversation around the topic that we covered on the live stream, that's where we discuss them post live stream. We can go ahead and drop that link in chat. We have time for a couple more questions though, so let's go ahead and do those before a couple of us have to, unfortunately, head over to other responsibilities.
I've got an interesting one here too, since these are basically in many ways blueprints, and I just said that they're not ticking. Would it be possible to have one that does have something inside of it that's dynamic, that does move in the space, or that does calculate something
Yeah,
at
yeah,
runtime?
yeah, sure.
Yeah. So nothing
I mean,
keeping
the
like having like a something that's tweening back and forth, right? Other than just like particle systems that exist as they are, but something that's actually running like game logic in it.
yeah, I mean, if just trying to think of an example. I guess if you wanted to explode one like live, you wanted to have it like kind of just do that kind of big rip apart and then pull back together or something. All you're doing is you're just spawning actors. So you can do that. You could do that in construction. You can do that in editor only, or you can call that on a custom event that fires when the player presses the P button or whatever. That's absolutely fine. You can do that as well. All you're doing is spawning meshes, which again you can do in Blueprint, either in game or you can do it in editor.
And I guess that'd be the case too if one of these assets that you're adding is a blueprint actor. I mean, it's basically the same thing, right? Building a one of these out of blueprints as opposed to just using static meshes or particle effects. That seems to be within realm of reason.
Yeah,
we did that actually, Chance, if you remember, the 11th hour with the.
Yes, I do. I remember. Yes, I recall it completely. That's right.
Yeah. So we appended basically like a particle or physics-based effect that had like rocks that kind of just sort of fell down the scree. And so yeah, I mean that was something that was appended to a mass. And so yeah, there's definitely the possibility for that.
You can get like real results in game, real results in editor that are responding to things that are happening in the logic loops. Very cool. All right, I'm trying to dig through here and see if there's another couple we can grab before we've got to bounce.
Yeah, we covered a few with that one alone. I guess just to make sure that we dive into that properly, it is then possible to reference, say, a specific pact level and its children to modify just that one and not all of the instances of the pact level that is in the scene.
So you'd have to break that level, and then make the edit.
Okay, so in the example here that Ambiguous Interactive was suggesting, it was sort of having a door in this mass blueprint, and only have one. Say there's 5 of those in your scene, and only have one of those 5 open its door. Would that have to be a broken or a split mass blueprint from the other ones to activate that one individually? Could you reference just one of those 5 and have that door open?
Yeah, I mean, sure. It's like if you're talking at game time, yeah.
Correct.
So right, if you basically made a prefabbed building that had some intelligent doors in them, then you could walk up to that door and it would only open that door, right? If you go into its volume or however you decide to have that door open, it would only open that one. It wouldn't then open all 5 of those, right? Unless you made it do that. but
Which you
but it's,
could.
yeah, which you could also do.
Yeah, but basically the instance is associated with the actor that you placed in the level, and so if you're interacting with that actor that's placed in the level, it's going to be that actor and not some super version of it that's going to affect everything.
Yeah.
Well,
No-
super is the wrong word, but static version.
Another question from Elise Bertrand, who's wondering, if you have a modified mega assembly, can you lock its state to avoid modifications from commits from other instances?
So the only way that you can basically preserve the changes that you make to a mass that you only want to happen to that one mass is by breaking it first. So you have to basically break out that particular mass, and then you can make any of the changes that you want to, and it won't update it. The way that the pact level blueprints work and the way that mass work, because they are pact level blueprints, is that they will always hold that reference to that particular level, and then they will always basically do an update to that particular level to make sure that they're in parity with all of those. Fortunately, there's not at the moment a way of you saying just stay the way you are, which is something that I'd like, because we did do some experimentation with actually doing some intelligent culling of pack level blueprints, where kind of if you had a bunch of them that were intersecting, you could get it to do a collision or visibility check, and it would then delete all of those extra ones. But unfortunately, that worked right up until you pressed play or you reopened the level after saving it. It would just respawn all of those, because they're like, hey, this mass isn't correct. It's not the same as that level, so it just reloaded them.
And just to verify, because we had a question from Tonshi Jukic here. These are all just like any other U asset that can be referenced and committed to source control and worked on just like any other U asset, right?
Yeah, and because they're referencing a level, and that level can have external actors, those actors can be referenced at the asset level through the external actors system.
Yep, we wouldn't have been able to build it without that. So
yeah, you have a huge
source
level of granularity with source control. So not only can you check out the mass or the pack level blueprint reference in a particular level, you could also check out a rock inside the level that particular mega assembly or mass is using.
And shameless plug, if you're interested in source control, Aaron did do a live stream on how to set up source control with Unreal Engine about a year and a half ago now, even longer.
Well,
Ooh,
we'll probably need
pre-pandemic.
to do. We probably need to do another one.
I think
Now
it's
that we have one
man,
file per actor.
yeah. We'll let y'all know when
Right.
that happens. All right. I think with that we have covered the general scope of all of the questions that came in that were on topic. Once again, feel free to continue asking them on the forum thread that we linked earlier. You can also find that in the description on the YouTube page. And usually post-stream at some point, we also update the Twitch VOD with that link as well. Aaron, Galen, Chance, anything else y'all want to mention before we wrap this up?
We'll have a lot more to say about mega assemblies, specifically like from a Quixel perspective, and the different packs and everything like that we're hoping to make. We'll have more announcements on that in the coming months. And I think one other asterisk we should put in, I think Aaron, you mentioned this, but the name Pact Level Blueprint is likely subject to change. It's something that we've heard from the engine team. So if you download the engine today, it will obviously be called what it is, but just look for that as something that could potentially change the vernacular there going into 5.0. So
Well, just to double caveat that as well is that because it's UE5, right? All of this stuff is potentially subject to change. So it's one of those annoying things that this is really cool new tech, but it is new and it is still in an experimental state. So this stuff may change. It may look completely different in the final release of UE5. But this is all stuff that we just want to make sure that you're able to take a look at, and to play around with, and to try out and give us feedback on as well.
Right. Yeah, that's like everything in Unreal UE5. I think, Galen's mentioned it on a handful of streams while we've been here. Building this project in general for us in many ways was trying to sort out how a lot of this stuff works. And we're really, we've been super happy to be able to share a lot of what we've learned with you, both in these live streams and in blogs and in, the actual video and giving you the project and whatnot. And so we really do value your feedback on how these things are used. So if you're out there working with mega assemblies, with pack level blueprints, whatever they may be named in the future, you're trying to do specific things with this, don't hesitate to ask questions on the forums, or like kind of share your work with the team so we can understand a little bit about what you're trying to accomplish, what your needs are with them, and what your wishes might be, so we can take whatever we can into consideration as we move towards that production ready release later.
Yeah, I mean, some of my favorite stuff that's actually in the editor now is like community driven, like, or even has been
Right.
kind of made by the community. Like we got named reroute nodes a little while ago in Unreal, and I absolutely love them. They're like the best new thing to come into the material editor for a while, and that's come from the community. That's someone who actually coded that and submitted it as a pull request. So it's really cool to get that stuff come through.
Yep.
Thank you all, and for all of you out there who have been watching since the beginning, thanks for sticking around. If you're interested in more Unreal Engine content, you can head over to unrealengine.com. If you are new to game development and the, I guess, Epic Games ecosystem in general, you can go to the same web address, unrealengine.com, download the Epic Games launcher, and download Unreal Engine for free and get started. There are a whole lot of learning content available on both on Unreal Online Learning, our YouTube channel, as well as the community wiki, forums, Discord, unrealslackers.org, all great places to not only find information on how to use Unreal Engine, but also interact with the community if you have problems, questions, or are just interested in seeing what others are doing. If you are watching this stream not live and on YouTube and on Twitch, we do transcribe the entire live stream. That script usually goes live a little bit week after we're done with the live stream. We also upload the PDF for that, which you can download and search for keywords in the script if you're looking for that time slot where we talked about them. We also timestamp the YouTube video. That usually happens a little bit before the manual transcript, I should add. That's why it takes a little bit of time. We actually manually make sure that that's accurate afterwards. But those timestamps will be usually within 24 to 48 hours on YouTube. Let us know what you think of today's stream. We'll go ahead and drop a link in chat here for the forum. Let us know what you'd like to see in the future. Now, I should let everyone know we do have streams booked up until almost November at this point. We got a lot of really, really, really cool content coming up. even, and it's going to be a little bit of a mix between U4 and U5 actually here in the future, with 427 just around the corner. But make sure that you show us all the cool projects you're working on. You can get in touch with us on the forums, on Discord, Twitter. They're all great places. Or if you want to email us, be a little bit, perhaps you haven't told the world about your product yet, you can go ahead and email community@unrealengine.com. We are looking for more countdown videos. We are sort of running at the end of our Australia Short Film Challenge videos. If you are curious about that, you can go ahead and either ask us about that at the same email address, community@unrealengine.com, or just go ahead and send us about 30 minutes of game development, fast forward that to 5 minutes, and email that to us separately with your logo, and then we can composite that together with the countdown afterwards. If you stream on Twitch, make sure you use the Unreal Engine tag as well as the game development one. Those two are usually good for us to be able to find us and others to find your content on Twitch. And make sure that you hit that notification bell on YouTube to see when we go live there, if that is your preferred platform. And next week, we are going to have Aaron McLaren and Dan Reynolds on to talk about Metasounds and Quartz. I would highly suggest, even though you are perhaps not an audio designer or an audio programmer or someone who's implementing or working with audio in any way, that you actually tune in for this live stream, because it has some serious implications on how one will be able to work with audio moving forward in Unreal Engine. I was doing prep with them just yesterday, and watching Aaron McLaren sort of just procedurally generate music in the editor is quite a spectacle, and it's great to have him on stream. So I highly suggest you tune in next week. That said, thanks to Aaron and Galen, and of course Chance once again for helping us out with the stream today. And yeah, we got some more live streams coming up with U5 content, so this is not the last you get to see of Chance. I was seeing some people really happy to have him back on the stream, which I absolutely agree with. It's quite the honor, actually.
Glad to be here and see all y'all, chat with you again.
Cool. With that said, I wish everyone to stay safe out there, and we'll catch you all at the same time next week. Take care, everyone.